Okay, let's do the thing. Welcome aboard, everyone, all two of you. So, basically, last time we were parsing a ROM, we were creating this NROM mapper, we figured out where the reset vector is. It points to somewhere a little bit weird for the NES test ROM, and so we're basically just going to do what the documentation says, which is to run it as though the reset vector were C0, and it will just run the tests in sequence. Of course, it won't do that because we don't actually have a CPU, so that's what we're going to have to do now. But first, let's move some of this stuff into the actual library, because I'm going to keep a lot of this stuff around. And mapper. The plan here, basically, is I'm going to set up the NES test stuff as a test. So Rust has the ability to set up tests both inline and also as like separate executables. And so I'm going to make a test, which is specifically for NES test because we have to do this funky patch thing to get it to work. But first, let's just make sure that my NROM mapper still runs, and it doesn't. Where is NESROM then? Is it not pub? Probably. Where is the NESROM type? It's right there. What the heck? Oh, it's because I moved it and it didn't import. Okay, I see what's happening. Boop. Use. Okay. Leave that alone. Use of undeclared type or module red. Okay. Struggling with modules again. Unused import. Can't find type NESROM. I need crate, that's why. Thank you, Rusty. You always know what's wrong. And create mapper. It's not found because it's in here and it's not pub. So let's do that. Can't load private type because the NROM is there. Get byte is not found. Oh, because it needs to be a pub trait. Makes sense. Okay, there we go. We're back to where we were yesterday. We just shuffled some of this stuff into the main library. And now let's go ahead and make a test. I'm probably going to have to Google how to do this. Rust cargo integration test. Okay, so we just need to tag it with test. Hello world. And this should just run, hopefully. Main function not found in create support. Okay, well, yeah, I need that already. Hello world. Will that work? Yep, okay, there we go. And we want, I believe we need that extern crate still. And then use red NROM mapper star. Okay, so now we're going to move the stuff from that example that we wrote into our test. Actually, I should open this in the same Vim window so that I can, copy stuff. We're just gonna yoink, boop, and then we're gonna replace main like so, and we're gonna have to run ourselves. Gonna have to fix a bunch of problems, of course, which is unsurprising. We need gumdrop. We need nrom mapper. I think we probably are gonna need INS also. Can't use a question mark, of course. Unwrap. And there shouldn't be a return. Okay, great. Called unwrap on an error, which makes sense because our test ROM is not being passed, actually. Come to think of it. So I need to do this. Test nest. Test failed. What are you? Okay. That's annoying. Hi, Diana. Why is it not telling me anything interesting? Oh, it's probably running parse ars default or exit and failing to parse the args. Okay, let's not do the or exit thing then. And expected one parameter. It's very annoying. What's going on here? We just fail immediately. Oh, probably you can't pass arguments to integration tests. Let's do that. Hi, Organ Harvester, Breadfish. How's it going? Can you pass arguments to Rust integration tests? Probably not, so I'll just hard code it. That's fine. So we'll get rid of gumdrop. We'll hard code this path to be nest.nes. Actually, it's probably not a .. slash. And there's no such thing as options, but we don't need any of this anyway. Just blow it away. Here we go. So we failed to find the file because, like I said, it's probably not .. slash. Because I'm running it from the main root there. There we go. And if we say no capture, then we'll get the printout, which says that our reset vector is C04. So the first thing that we're going to have to do is patch it, basically. So let's add some options here so that when we go to create the ROM from file, we can also do it from an array. So from bytes, and then we'll take bytes is a slice of U8s. And then the only difference, actually we'll just call this contents. Get rid of that. Can you enlarge font? Yes, I can. Good point. How's that? Better? Maybe one more. Okay, good. That's an excellent point. Completely slipped my mind. Thank you. Okay, so we're just going to make from file call from bytes. Oops, no semicolon. So hopefully that'll work. Expected borrow. Cool. Okay, so now what we want to do is in our test, instead of doing from file, we're going to do this exact thing. Test.nes. It still is not a .. slash. I don't know why I keep doing that. And then we're going to make it from bytes here with a borrow on contents. And that should be functionally equivalent. But it's not. because, okay, first of all, unwrap. Second of all, we don't have read, which makes sense. It's from standard FS file. Standard FS, rather. And there we go. Okay, so that's identical. And now what we're going to do is we're going to go to contents, FFFD, which is the upper byte, is going to become C0. And FFFE is going to be 0, 0. And now our reset vector should be C double O's. Oh, well, yeah, that's not how that works, is it? Cool. Okay. What's the best way to do this? I mean, I can just patch the ROM directly. It's kind of annoying. So there is a 16-byte offset for the header, and then there's a, well, I've got this open. Where is it? INS format. Okay. 16-byte header, and then the ROM data, which is 16K times X bytes. And if I remember correctly, the NES test ROM is only 16K. So that means we want contents 16 plus 16K minus 4 is C0, and minus 3, oops, is 0, 0. And let's see if that works. A little sloppy. Reset vector C0, so not quite, but close. Because this is backwards, that's why. Okay, there we go. Now we have a C0 test vector to use, which means that we need a CPU. 6502.rs. Let's do the thing. Alright, struct CPU. Okay, so 6502 CPU.text. Oops, it's not a website, it's just a search string. You bastards. I know there is a cool little data sheet thing. Where is it? .txt, quote, quote. There we go. That'll work. Raw. How's everybody doing today? I'm just kind of been chatting to myself, I guess. Which I suppose is forgivable. It is my stream after all, but still, I want to see how folks is doing. If there's anything in particular that you're excited to look at, let me know, I guess. Okay, so we got a U16 program counter. We got the S register is an 8-bit offset, okay, to the stack page. You've got the processor status page, which I suspect I will have a lot of convenient accessors for, because it's got a bunch of different flags. There's the accumulator, which is also a U8, index, also U8, and index Y. Okay, so those are our registers, which we should probably make as a struct themselves, come to think. So we can just keep things nice and organized. Oops, too far. Okay. And when we initialize the CPU, we're going to probably want to do it from the ROM. So we're going to want to do cleaning bird cage. I'm glad the bird is warming up to you. So we're going to want to do with ROM, or mapper, really, is what we want. We're going to do mapper comes from not here, but the other one. Trait mapper, so we can do impl mapper, I guess. And then we'll return a CPU. And then we will copy this bit out of here. And we will say that we return a CPU with a PC equal to the reset vector. And I guess we want to zero all of these out. I mean, it seems like most of them would probably want to come up as 0, but maybe P doesn't. Negative overflow. Current knowledge, this flag is always 1. See, this is why you check these things. So that's 80, 40, 20. Software break instructions is always set except when P is being pushed on stack when jumping to an interrupt routine. Okay, so that's 30. Decimal mode is 0 most of the time. Interrupt disable. I don't know. I guess it probably comes up as 0. 0 and carry. So let's bring this up as 30. And then, oh no, that's the P. My bad. And 0. And A. I probably don't need these U8s. It will just figure out what I need, but whatever. Oops. Okay. Is that build? Yep. Alright, now let's replace. Oh, I need to use crate nrom mapper star. Yeah. And then in here, instead of doing this, we'll do let CPU equal. We'll just do that. I wonder if that'll even work. Are you allowed to name your module starting with a 6502? Probably not. CPU with mapper. And now all the things will fail. Expected identifier, yep. Fair, let's just change it to CPU. Could not find CPU in red because I didn't pub it. Makes sense. What? Yes, it does. Oh, okay, duh. That's my bad. Alright, let's close this. Source CPU.rs. Okay, so the reason that didn't work is because I didn't wrap this in a register declaration. Obviously is necessary because I decided to split up those fields. Choo. Use of undeclared type or module CPU. Unused import red CPU. That's interesting considering those two things are directly related. But let's just do it this way, I guess. Struct CPU is private, that's why that's happening. Yep. Always get that wrong. And the method is private. Borrow of move value mapper. Oh, because I'm still doing this, and then what I want is cpu.regs.pc, which is probably also going to be private. Yep. And honestly, it should stay private, so let's do this instead. Of fun get PC self 216 self.regs.pc. Okay. That compiler looks awful. What do you mean? Is it because I have 50 billion warnings? Or just because it keeps complaining that things aren't public? Yes, it is true that I have a lot of warnings, and it's because it's trying to build main and a bunch of stuff. I don't know, it'll get better. By the time I ship it, it will have no warnings. This is my commitment to you. Alright, so that works. That's cool. Now we need to actually do the execute bits. So the basic structure of how I want to run this, which is absolutely massive overkill for an NES emulator, and I'm aware of that, so don't tell me. But basically what I want to do is I want to have a queue of micro-ops, basically, that represent the actual cycles of the NES emulator and emulate at that level. And the reason I want to do that is because it's what I want to do for my N64 emulator when it comes down to that, because that has a 5-stage MIPS pipeline, which I want to emulate faithfully. This is sort of the opposite problem. It's like a 6-stage or 1/6-stage pipeline. IPC less than 1, obviously. So this is not necessary at all. I could absolutely do this in a different way, but I think it's a pretty natural fit for like how stuff works in the NES, and it should make getting sub-cycle accuracy a lot, or sub-instruction accuracy much easier, and that should make things like Battletoads work. So to start, let's do fetch instruction self. You are going to fetch U8, which basically just means, oh, actually the CPU needs access to the mapper for sure. Unexpected close parentheses, huh? Where? Oh, because I didn't finish this. Mapper get byte self.regs.pc. Expected trait found type parameter. The size for values of type cannot be known at compile time. This is what generics are for, you little butt. Imagine not using your own function SMH. I'm in the module. Why would I need to use getPC? It'll just inline it away anyway. Do you have to explicitly type out the this pointer? Yes, because you can have associated methods that don't take a self, which is like this one right here, impulse CPU. This doesn't take self, so it's what's called an associated method instead of an associated function instead of a method. Okay, what's your problem, buddy? You want me expected traits. Oh. Duh. That's why. And this should probably be an M. Gorammit. Okay, wrong number of type arguments, right? Because I don't say M here. Did you mean CPU? Wait, what? Oh, no, it's up here. Duh. Okay. So like a static function. Yeah, basically. Very similar to a static function. In this case, it's being used as like a replacement for a constructor, basically. Rust doesn't have like a strong constructors convention, which is one of the things that confused me the most about it when I first started. So when you're inside, when you have like interior visibility and you have access to the struct, you can just make one like this, and then if your struct has any like private fields or whatever, you won't be able to do this because you won't have access to the private fields. So that's why you find these public functions that do have that visibility, and that's the equivalent of a constructor. But it took me a while to figure that out when I first was starting to learn Rust. Okay, so that is fetch instruction. Let's just try that out. Fetch instruction. Very weird. Yeah, there's been some Twitter hashtag discourse about where Rust chose to spend its weirdness budget recently, which I think is not entirely unearned. Is it a JIT language or is it compiled down to x86 bytecode? Yeah, it's compiled all the way down. It has support for a bunch of other architectures also. Basically anything LLVM supports, Rust can emit because it goes through LLVM in the back end. Gotcha. Alright, so now we want to start actually emulating instructions. This one is 47, apparently. I saw a really nice instruction table in one of these tabs. Where is it? Actually, first let me double check this listing and make sure that that's actually true. That's a C, so that doesn't seem to be right. Odd. What did I do wrong? Oh no, I just forgot the thing I read 2 seconds ago. Everything's fine. Alright. Where are you? Instructions, mapper grid, memory map, flags and stuff. Okay, maybe I just have to look for it on NESDev. Doop doop da doop da doo. CPU instructions. Instruction reference to flag behavior and timing. Sounds nice. Programming manual, 2x3 construction breakdowns, which I was just looking at. Okay. Opcode 4C. What do you got? Addressing mode absolute is all I get back. Oh yeah, that makes sense. Jump absolute address. I saw a thing that was explaining how this worked. Here it is. This is what I was looking for. Let's see, is that legible at all? Tests with log outputs. NES must be so much easier to Emulator for. Yeah, right? You'd think this would be standard when you have a test ROM that you would post like, hey, here's what it's supposed to do. Also, here's the source code. But no. People are lame. Okay, so you take a look at this. We have so bit 0, 1 sort of like picks the bank basically, and then the upper bits pick the instruction, and then the middle bits are like the addressing mode, more or less. I swear there was another thing that was like, hey, here's the nice description. Maybe it was this one? Nope. Oh well, it's fine. I'm basically just going to implement them all anyway. So there is a nice pattern. OMG, you look just like your profile picture. Thank you! Half the time I show people that, and then they see my actual face, they're like, what? You don't look anything like that? I'm like, yes, I do. I look exactly like it. This guy was an excellent artist. Look at the EmuDev Discord. Where? Why? How? Okay, I'm looking. Not seeing anything. I'm seeing Sai typing. Your hair is darker. Yeah, that might just be the lighting in here, which is not very good. Me confirmed, dab on the haters. Yeah, I figured. You don't, no offense, Sai, but you don't seem important enough for anyone to impersonate you. Okay, so enough talk. Have at you. We are going to just make a big high velocity. We're just going to make a big array or a big vector, basically. But how do we want to do this? Let's just do it this way. We're going to return an array of vectors of microcode, which I haven't written yet, which is going to be 256 long. Microcode is going to be a struct. Hey, Rust. Yes, it is indeed Rust. Is that you, Jeff? And so we're just gonna do one. Back. How do we want to do this first of all? With capacity 256. Why are mappers templates on the CPU struct? I don't know, it seemed like the thing to do at the time. It's not like mappers change during execution. Keep your mappers separate. They are separate. They're different types, different structs. I don't know, maybe it's a bad idea. I'll change it later if it's a bad idea. Okay, so what was I thinking of doing? Right, so I want to do vec microcode. Probably would have figured that out, but whatever. And then what I want to do is result dot resize with. My suggestion is have some sort of interconnector bus class that the CPU has access to, then keep the mapper on the bus. Yeah, I thought about doing that. It's obviously like the sensible thing to do, I guess. Syntax looks too much like Swift. I don't know how to feel. Okay, so not Jeff, because Jeff doesn't write Swift. I thought about doing the mapper or the bus thing. I've definitely done that before. I don't really know. I guess the PPU is going to write to something somewhere. That's the only thing. Because really where a bus struct seems to make sense to me is if I have a lot of different components that all need to share access to memory, which is kind of true, but also kind of not true, I guess. I don't know. Maybe I'm underthinking it. But that's an easy change to make later. Right, so then I was going to do result, because we know for C, actually I should probably make that a const, what is it called? Just jump absolute. For C. We're going to do result jump abs equals something. Your main components on the bus with PPU, APU, main RAM, and some MISC I/O registers. Yeah, so the I/O registers, I was basically going to let the CPU poke. The PPU and APU, I guess, is a pretty good point, actually. So I'll probably make that change shortly, but I'm going to stick with this for now until I have the CPU working, and then I can worry about the larger architecture. So we're going to jump. It takes 3 bytes. It takes 3 cycles. So what do you actually do, friendo? Jump. Yes, jump abs is what I'm doing. So what do you do exactly? Okay, maybe you're not where I need to be. Okay, absolute addressing. I'm not fully certain how much control the mapper has over the bus. At least MMC5 can snoop PPU writes, but for the most part, your mapper only needs to control. Yeah, that's basically the idea. Is when I have my like access memory functions, if they are in that range, I'm going to just delegate directly to the mapper, and otherwise just do it directly from the CPU. That's my current plan. Again, given it's a PPU and all that junk, it may not actually make any sense to do that. But that's where I'm at right now. Okay, is equal to vec. So the first thing we need to do is fetch opcode increment PC, which everybody does that, but okay. I don't think I want to include that. So the next thing to do is fetch low byte address increment PC, and then we're going to do copy low address byte to PCL, fetch high address byte to PCH. Okay, can do that. Where do I fetch it to then if it's not getting fetched to PCL? BRB going to do some chores. Okay. Anyone who is not directly from EmuDev Discord, welcome. Also, the people who are from the EmuDev Discord are also welcome, I guess, but they're also less surprising. Do loads of emulators use a bus to connect things? I normally just give everything a pointer to a memory class, lol. That would not go over well in Rust, probably. It could maybe conceivably be made to work, but it seems fraught. Also, enough weird systems do enough weird things with memory that it seems worthwhile to have a separation. Okay, so let's think about microcode for a minute. I did basically pull this up. So a while back, when I was originally brainstorming this sort of architecture for an N64 emulator, I came up with a way to actually do it in Rust that doesn't look terrible in terms of performance and adding a bunch of extra dereferences and dispatches and stuff. And it's basically gonna look like, look what just happened. Here's the thing. It's gonna look like this. What is going on? Gosh dang it, Firefox. Okay, there we go. So when you say velocity, when you say that you do that in C++, you mean, by that you mean have a mapper class. Or you mean give everybody a pointer to shared memory. Okay, so the basic idea here is that we have a structure, which is a microoperation, which has a function, and also maybe takes some arguments. Not sure how much sense that makes in NES land. And then we have handler functions, and basically this function has to be a handler function. And so what we do is when we're processing the microops, each of them is going to have a handler function associated with it, and then we're going to just kind of go through the queue and pop it and run each microop, some of which will fetch and add more microops to the queue, others will not. And so basically with this design, the intention is that there's not actually a lookup in the main loop. There's only an indirect jump, which this seems to be doing. I don't know, hard to tell. I remember thinking that that worked here. So buses link devices to memory in the actual system then. Yeah, that's what I would do probably. Just have some representation of the shared interconnect. Especially in later systems, I bet they get more complicated with like bus contention and blah, 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 blah. You have to kind of like deal with that. Again, depending on how accurate you actually want to be. So Alright, so you have function, which is going to be let's just say unmute CPU for a moment, and returns nothing. Each instruction would be 2 to 3 microops. Yes, exactly. So if we look at the thing I was just looking at earlier, I have too many tabs open here. So if we look at this instruction here, which is absolute jump, on cycle 1, it fetches the opcode and increments the PC. On cycle 2, it fetches the low address byte and increments the PC. Cycle 3, it copies the high address byte, or copies the low address byte to PCL, fetches the high address byte to PCH. I don't know where this fetched to, given that it's obviously not PCL, but whatever. But yeah, so that's the idea. Each of these would be a micro-op instruction. And then hopefully we'll just be able to reuse a bunch of them and combine them to create the various effects, which appears to be how the actual hardware works based on the stuff that I've read, the fact that there are these undocumented instructions. It basically, there's like a sparse decode ROM in the NES that produces some of these effects, and we're just not going to bother with sparse. We're going to do dense, but it's going to be basically the same. And that's this structure that's returned from instructions is going to represent that decode ROM. Okay, so you first thing are going to fetch. Okay, info microcode. Public function fetch. And you are going to take an argument, ideally. Neat, I just read about some guy using Rust generators for that with yield and such, but it's unstable. Yeah, so that's exactly it, right? I looked at that post also, which was very cool. And after I got over my, like, damn it, I was going to do that reaction, which is something I'm trying to work on. Yeah, generators are unstable, and that's basically libco, right? Like what Vue does in BSNES. Generators are just like fancy coroutines, or syntactic sugar for coroutines, or whatever. And so I think it's a good approach, obviously. I mean, BSNES is great, but I want to try this out because I think this would work really well for something that has like a multi-issue pipeline, like MIPS does for the N64. Hi, Sai. So you are going to want to take an address to fetch from, maybe? Yeah, I think you are. So address C16, you're going to return a microcode object, and the microcode is going to be, how far am I into my N64 emulator? Not. I got really sidetracked on a bunch of stuff that was interesting, but perhaps not the most productive thing. For example, as Sai will tell you, it has a very, very, very fast MIPS instruction decoder, which I generated using a super optimizer that I wrote, which is really cool, and it downloads like, or it decodes rather like something like 3.5 cycles. There's 3.5 instructions on average per cycle, or something like that. It's very fast, anyway. The fastest black screen N64 emulator on the market. Yes, that is true. All right, so we're gonna want to do get byte with address as our function in our microcode, which means we need to actually implement it here. Or no, actually, we gotta fetch instruction, which is literally just get byte. So I guess we'll just do that. As far as SMB3 goes, it's not super demanding, but it does require fairly accurate CPU and PPU timings. Yeah, that's about what I figured. I mean, I guess you don't know me that well, but I suspect it will come as no surprise to you that I am unlikely to implement something that is inaccurate. Because I'm a crazy person. It's weird that you expect me to have a type argument in there. But okay, I guess. That's Emudevs for you. Yep. Wrong number of type arguments. Oh, yeah. Shut up. Stupid thing. I'm gonna regret this, aren't I? Should have just boxed it so I don't have to thread generics everywhere. Oh, yeah, it helps if you actually return your results. Is there a to array? Expected function pointer found closure. That makes sense to me. And the vector cannot be indexed by U8. Well, that's easy. There is no to array. Is there like an into, maybe? Nope. Huh. Oh, I bet this is because that field win no const generics. I can actually probably get away without this. So let's do it this way. The map rate uses MOC3 as a scanline counter based on PPE reads, uses this for changing score registers mid-frame so we can display a status bar on the bottom. Let's see if that works. Okay, so the main problem is going to be that. Are there any other problems? It takes one parameter, or takes 0 parameters. Huh? No, it doesn't. Oh, I guess it does, because it used to be called fetch instruction. Fine. P16. Okay, expected, nothing, found U8. So what are we going to do about that exactly? So where does, so I was looking at this earlier, but you weren't here. So I'm looking at the description for absolute addressing, right? And on cycle 1, it fetches the opcode and increments a PC. Sure, fine. On cycle 2, it fetches the low address byte and increments the PC. But then on cycle 3, it says copy low address byte to PCL, fetch high address byte to PCH. Where is it fetching the low address byte to? Is this the instruction decode latch that I've read about before? Is that where it goes? I don't know about that instruction decode latch thing. Is your question where the CPU reading the bytes from? No, my question is where is the CPU reading the bytes to? Where is it storing the bytes? Good night, Oregon. Have a good night. Sleep well, etc. Yeah, the latter. Where is it storing the bytes? Because here it says fetch high address byte to PCH, which makes sense to me, right? You fetch it directly. But then here it says copy. So I'm thinking that is 6502 block diagram. I've seen a thing that shows this like instruction decode latch thing, or pre-decode register. That's what it's called. So maybe not. Program counter low select register. Yeah, I understand that. Interesting. So what I'm confused by is the two-stage nature of it, right? I mean, I can just shove it someplace and say like, oh, it lives in the ether someplace. But like, it is pretty clear that the copy of the low address byte to the low byte of the PC is not done until after the fetch, which makes sense because you would move the fucking PC and then your high address byte would be fetched from somewhere else. So where is it going in the meantime is my question. DL. It's probably this thing, I'm guessing. Input data latch. Yeah, I'm wondering where the low byte goes before it goes into the PCL. And I'm guessing it goes in here somewhere. I guess it's some sort of latch. Yeah, see, so, okay. Input data latch. That's what we're going to call it. That's where we're going to stick it until and unless we learn otherwise. What did I have for how this was going to work? I don't know the details of that, but as far as... Yeah, I know. This is what I was just saying. Like, the problem here is not that I'm going to be not accurate enough. Where's my fucking notes? The problem here is going to be that I don't finish because I have all these crazy ideas, which is fine. Who cares? You could just as well make a variable called a waggle rocks and store the byte in here. Look, I get that it doesn't matter to you, so I understand. Okay, so how did I do this and why did I do it that way? I have an enum. I have free functions. I implemented from for handler function, which is the enum, for the function pointer. And then I just call from. So that's what I'm doing there, as opposed to here where I was going to do like a factory thing. Which I think is fine to do it this way, except it won't work because there's not going to be a pointer. Remember, completing the challenge and getting that nerd credit is all that matters. I mean, yeah, there's some truth to that, I guess. All right, here's what we're going to do. Fetch to input data latch. And mute CPU. And you're just going to do cpu.idl equals cpu.get byte cpu.pc. And this is probably not a great way to do this because it will probably want to be parameterized later. And we don't have constant generics, but that's okay. Fetch to IDL, and then this should actually build. Of course it does not, because that's not how that works. A lot of stuff here doesn't work this way. Yes, you do need, in fact, a type. Does get byte just do a read from memory? Yes, but it will do a read from memory through the mapper if it's in the right region. Eventually, which it doesn't do yet because it's not in the region. Actually, I guess it always does a read through the mapper right now, and eventually it will not for some things that are low enough. Expected mutable reference found struct CPU. What? Expected that type, found that type. It is a mutable reference. What are you talking about? What's said about the generics? Small recommendation, create a fetch byte function that reads from memory using the PC and increments PC at the same time. Yeah, that's a good idea. That's a pattern that's going to show up everywhere. Hello, welcome aboard. Are you here from the EmuDev Discord or from my Twitter or somewhere else entirely? Yes. That'll teach me to ask multiple questions at the same time. Discord, okay. If I get rid of this, it's not going to work because it's going to say I need a type parameter. And it's right. I should probably just box the mapper. I'm just going to box the mapper. It's not worth it. It's such a pain in the butt. Fix it later. Or I'll have a bus and then it won't matter. Yep. Oops. Just not worth it. Okay. Give me bus or give me death. What are you talking about? It's not a struct. I'm very confused. This doesn't make sense. That's not how types work. Oh, maybe it is. Okay. Whoa, what just happened? Oh, I hit caps lock. Whoopee. That feeling rusty makes you feel like an idiot. Yeah, I always get mixed up with whether the and mute goes on the type or on the variable because it seems to depend on like whether it's a pattern or whether it's self or whatever. Like I just get that mixed up all the time. Copy is not implemented. The repeated element will be copied. Okay. That's annoying. And then I gotta make it mutable, which, yeah, that's fine. Oh, I know what I need to do. I bet I can do just like vec.asSlice, maybe? Or there's gotta be a way to get an array out of a vector. I know you can make a vector with an array. And there's a thing which is like from raw parts. How do I get an array from a vector Rust? Or I could just return an array, or a vector, I guess. Yeah, whatever. I'll just return a vector. Who cares? Fix it later. If you want to get bonus points so you can get the decode ROM working. Which decode ROM? Because I might already be doing that. The 130 entry ROM the CPU uses to decode instructions. Yeah, so we just talked about that like 10 minutes ago. Or less. Where am I calling this? Line 17. So I'm not quite going to do that exactly as described, but what I am going to do is a dense decode ROM. Which does use all the same microcode, basically, except I'm going to actually combine it together. Instead of relying on like the partial decoding and the partial whatchamacallit, which I guess I could do, and it would be kind of cool, but I decided it was a little bit too much of a pain in the ass even for me. Alright, so that's good. What we want to do is when we initialize the CPU, we want to create a queue of microcode, which is going to be a vecdeec. I did try to look into it, but I didn't really understand how to decode the decode ROM. So basically the way that it works is that it has like a set of these must be 1 and a set of these must be 0 bits, and then a set of like this is the cycle that I'm on. And if you match if all your these must be 1s are 1, and all of your these must be 0s are 0, so basically AND it and OR it, or AND it and NAND it, and you're on the right cycle, then the thing that that line represents happens. And because it's not like must match this, it's these must be 1, these must be 0, multiple of those can fire at once. Is basically how I understood it. In terms of like what action is at which decode offset, I mean, I'm sure somebody's done that work. I didn't like find it immediately, but I'm sure it's around. That actually makes perfect sense. Thank you. I do know a thing or two about how electronics do, despite all appearances to the contrary. I would never. Okay. So we're going to want to start with a queue. I can never spell deek. It just seems wrong. Push back. Push front. Doesn't matter. Probably doesn't even exist. This is not actually what I want to do, but it's what we're going to do anyway. Cannot borrow as mutable because I didn't mark it as mutable, which is dumb. Alright. Oh, hello. Come on up. The people want to see you. Did I get that? Nope. Alright, hang on. How's that? Better? Sort of. Cat. He is a pretty boy. Look up at the people. Lift your face. Alright, you're not going to do that. Let's just do this. This is my cat. His name is Meat. Technically, his name is Meteora after the Linkin Park album, but I just call him Meat because nobody has time for that. Alright, let's not stare at my crotch anymore. That's that. Okay, good. Yeah, he's a good boy. He was named Meteora because he was found by the shelter the day that Chester from Linkin Park killed himself, which is a super depressing origin story for his name. His brother has a similarly Linkin Park themed name, which is Faint, which at least is not a Linkin Park song anyone remembers. So, shit, I missed it. What, the cat? I'll show you again. Anything's better than actual work. Look up, bud. Look at the people. There you go. He's a good boy. I agree that Hybrid Theory is a better album, but I didn't name him. The shelter named him. Okay, I was doing something relevant. Yeah, so I created a queue. I pre-populated it with the fetch operation that I created for the reset vector, which is like super not correct at all, but alright, so let's clean this up. What do I actually want to do? I think I still like this design that I had before. So what we're gonna do... Shit, I missed it. God damn it. We changed the names of our cats after adopting them. I thought about doing that, but I didn't. Alright, Pixel. Last time. Look up, bud. Look at the people. They want to see your face. There we go. He's a good boy. Yeah, I thought about changing the names, but honestly, I'm not creative enough to come up with a new name, so I just kept them. Okay, enum micro function. Just gonna call it that. I don't think I care about the repr currently, actually. All right, fetch byte, and then pull from microphone for fun and mute CPU. From microphone yields a fun and mute CPU. Match x microphone fetch byte. It's gonna yield fetch byte. Shit, I missed it. Lies. Okay. And then we're gonna So what do I want to do here? So I think I'm going to keep fetch to IDL. To be fair, I really did miss it. I know. I was giving Psy shade, not you. Ha! Thank you, Breadfish. You are a gentleman and a scholar, or possibly a lady and a scholar. Or possibly something else and a scholar. Whatever you want to be. Scholar is not optional. Alright, Alright, so this is fetch to IDL, is we set the IDL. And then the other thing, I'm going to just drag over here because this is really annoying. Oh, maybe I already did that. Where are you, friend? There you are. Okay. Fetch low address byte increment PC. Copy low address byte to PCL. Fetch high address byte to PCH. Okay. So fetch to IDL is fine, and then fetch and copy. And mute CPU. CPU.pc equals CPU.idl or CPU.getByte, CPU.getPC, left shift 8, and I need to do CPU.regs.pc plus equal 1 here and here. Imagine getting me confused with the poop man. Le gasp. Okay. I feel like that wants to be somewhere else, so let's just do it here. This needs to be immutable. Regs PC plus equal 1. I wonder if other people are like coming to this stream and then being scared away by all the talk about poop. Probably not, but it is at least possible. Oh, and then it needs to actually return something useful. I blame Ziff. To be fair, it's usually a good bet. Whoa! Oh yeah, okay, fair. Ugh, CPU.regs.pc, damn it. I mean, we could, is the thing. We absolutely could. Y'all appear to be unwilling to, but that doesn't mean we can't. I can say the same to you. I don't participate in the Ziff memes. Oh. That's type, not a field. But I am on the server. It's true, but that doesn't mean that Ziff memes are a requirement. I actually had to block Lila, not to block Lila, but just so that I didn't scroll through the Discord at work and see Ziff's balls hanging out of his eye socket. That coffee is cold. I'm going to have to go zap it. Speaking of fates worse than death. Alright, we're just going to drag all of that junk. And then instead of having microcode fetch, we're going to have... Oop. Wait, what? What am I missing? Yeah, don't ever join that Discord. It's terrible. Oh, he's so cute. Okay, what do I want here? I think I just want a new microcode. Fetch to IDL. Is that how that works? Probably not. It's a variant, not a module. Yeah, I know. Does that work? Yep. Go away. It's not bad if you stay away from that one channel. I do not do that because oftentimes that's the only active channel and I'm bored at work and I don't want to do actual work. Which is why I quit out of Discord on days that I need to actually get work done. Okay, so now we have a queue, and now we just need a way to tick it, basically. Like right now. Yeah, exactly. Except when people tell me to go check to make sure that they're not being impersonated inexplicably. Alright, so... Do I want to execute just a single tick and drive it from somewhere else? Yeah, probably. That seems like the right thing to do. So we're going to do self... I need CPU. Self... I need self. Self dot q dot pop front. Let uop equal uop dot f self. Oh, okay. Unwrap. Oh, to call the stored function, surround with parentheses. I need that. Do. Okay. Now let's go ahead and do CPU.execute and see if it explodes. Cannot borrow is mutable because I didn't make it mutable. Boop. Alright, it didn't explode. Alright, so... Oh, okay, I remember what I needed to do now. I need to actually write a, like, do the fucking thing instruction. This is wrong. This is, fetch and decode is what we need. Did I just curse on stream? I curse on stream a lot. I'm pretty sure that's okay because I watch a lot of Simple Flips and he says fuck a lot. So I think it's okay. If I was going to start curbing my swearing, I would start with like meetings with the CEO of my company and not with Twitch. Yes, I should do that thing. Simple Flips isn't exactly Ninja though. I think the thing that Ninja said, if I recall correctly, was a little bit different than just saying fuck. Also, if PewDiePie teaches us anything, it's that being big on the platform makes you more difficult to kick off of it, no matter how terrible you are. Okay, so what we're going to do here is we're going to want to look up in the instruction ROM the opcode. So this is going to be a vector of microcode. And then we're going to do for uop in uops.iter cpu.q.push front back iter.reverse push front uop. That seems like the thing to do. And there is no instruction ROM currently, but there will be now. And then in this function that fills that out, it will just have to be called instructions, like that. And that should pre-fill it. Okay, fair. Needs to be as you sized. Well, there was that whole Nazism thing with pews, but it did end up being fabricated or at least distorted. I mean, I don't know enough about that to talk about it. No method named reverse. Is it like rev iter or something? I forget how this works. Rev. It's just rev. Thanks, friend. One thing I will say about Rust is that it can't decide whether it wants to be it can't decide whether it wants to be verbose or terse or explicit is the words I'm trying to say. I think it probably wanted to be terse at some point in its historical past, and then got kind of fucked up. That's fair, but then it won't. Then it'll be a reference. I mean, I should probably just make microcode clone or copy rather. Because it should be. It has type vec microcode, which is fine. This will just borrow here, and then it'll be good. Oh, gotta dereference the borrow. Fair. Boop. Pattern fetch and decode not covered. You're absolutely correct. This is the kind of thing that really needs a macro to like populate all this stuff. But I have to make sure it works first. Okay, it ran and then it exploded. Where did it explode? I called execute a bunch. Let's call it once, doesn't explode. Let's call it again. Does it explode? It does. Adding UOP to queue. Should maybe move the position of your camera to the top of that terminal. Oh, yeah. I totally am looking at the wrong monitor. Didn't think about that. That's too low. The fucking board is pulling it off balance. How's that? Better? It's a little bit cockeyed. Move the position you can. Is that not what they meant? What do you think they meant? Bush for dag, what did you mean? It's all cockeyed now, but that's okay. Oh, I see what you mean. Okay, yeah, fine. Let's do that then. Put my webcam back. I like it better over there. Cam is covering the newest part of the terminal. You're absolutely correct. Very sensible. Whoa, what was I doing? Oh, cool. Cool. All right. Printing UOPs. Yes, that's what I was doing. Thank you. So I can't just drive you up on microcode, but I can always just drive it here. And then make these into functions instead. Yep, that's all good news. And then this one will be microphone instead. Oh, that's why it's not working, because I didn't actually put the stupid functions in here. All right, microphone fetch to IDL, microphone fetch and copy. I bet that fixes my problem. Oh, yeah, okay. This needs to be F into the state from microphone is not implemented. Oh, it's because it's borrowed. Cannot infer type for T. Okay, thank you. Into fun and mute CPU. Is that going to work? Probably not. Unexpected type argument. Expected 0 found 1. What are you talking about? Why is this being such a problem for me today? Okay, cannot infer type for T. So the problem here is that it doesn't know. Look, hello, cat. It doesn't know how to turn a UOP, which should be a vector of microfunctions, right? So this should be a microfunction. And we want to turn the microfunction into the CPU. But for some reason, it's not liking that into there, even though it's obvious what it should be. Move occurs because it has microphone, which does not implement the trait, but it could because it's just an enum. So let's do that. And now we're good. Okay. Alright, there we go. So the problem was I wasn't adding them to my instruction ROM, which totally makes sense. And now what we're going to want to do, you're going to want to tick this 3 times, and then this almost certainly won't work, but let's see if it does. Nope. And I probably can't derive you either, can I? Stupid function pointers. Bite me. Alright. Do I even need the microcode struct? I could just get rid of that entirely. All I actually need is the into declaration. Okay, yeah, let's just get rid of that. Who cares? Actually, I should commit something, because I haven't done that at all yet. What am I calling it? I'm calling it RED. Rapid Emulation Development. More like red code. Hey, I had that name before he even existed. It was originally going to be for Pokemon Blue. So this doesn't even do anything, which is fine. It can go away. Once again, we just strip this out here. Push this in. I don't recall you ever talking about the mooch pet. Well, I was planning to just like do it and not make a big fucking deal out of it, because that's how Ziff gets in trouble. Oops, I already did that. That is the smart way of doing it. Yes, indeed. Certainly, the dumb way of doing it is to not only announce you're going to do it, but also then say you're going to stream all of it. Oh well. Ha! I beat you to it. Although maybe not for you with stream lag, so. You said it first. I'm not sure you did. I think that was just stream lag. We both said it first. I'm down with that. That's fine. Field expressions may not have generic arguments. What are you talking about? I must be doing this wrong. Alright, let's just do it this way. Let ufun tag fun emu CPU equal. Oh, that needs to be capitalized. Maybe that's why it's not working. Uop.at. And then we'll just call it directly. There we go. Yeah, I probably can now because microcode doesn't exist anymore. But registers do. And box doesn't because mapper doesn't, so I need to implement it for mapper also. But mapper is a trait. Why doesn't box work? Ugh, whatever. Fine, no debug CPU. Let's just print CPU.getPC. Because that's what we actually want to see anyway. Oh, shut up. Okay. Alright, new PC is C5F5, which I believe to be correct. Ah, Rust. Yeah, it's true. Still good, though. Where is the thing? There's like a listing that tells you what it's supposed to do. Here it is. Okay. Yep, C0, C5, F5. Awesome. Okay, that's correct. How long have I been streaming? I feel like I need at least to take a break long enough to microwave my coffee. At the very, very least. About an hour and a half. Okay, yeah, I'm going to zap my coffee. I'll be back in like 2 minutes. What's the challenge list? So the challenge is basically to implement an NES emulator that can run Super Mario Bros. 3 in 2 weeks. We never actually agreed on any stakes, which, in retrospect, probably should have done that first. But also, I can afford a pizza if Sai wants a pizza if I fail to do it. And also, if Sai doesn't buy me pizza, I can afford to buy my own pizza. So, you know. Yeah, so I'll be right back. I'm just going to zap my coffee and stuff like that. Okay. Got coffee, got water, pet the other cat, took drugs. Let's do this thing. So the next thing to do is to fetch the next instruction, figure out what it is, and then run it. Wait, that's not actually what I want, is it? Okay. So the last thing that should be in every iteration of this thing is fetch and decode next instruction, which is grow fun fetch and decode. And then anytime I call fetch and decode, instead of doing this, it says adding UOP whatever to the queue. So it should tell me to UOPs it adds, but it's probably also going to explode. Yeah, there's no get IDL, I get it. This is what I need. Print line, decoding, opcode, sharp x question mark, colon, comma. I feel like that's probably the wrong order for those. That's okay. No, works. Okay, opcode is A2. Oh, I should probably put some sort of assert uops dot len is greater than 0. Valid instruction. It's not how assert works, is it? Oh, maybe it is. Yeah, there we go. And I should actually print the thing with format. Oh. And then I can get rid of this. Okay, there we go. A2 is our next instruction. See where we're at with that. Where's my list O instructions? That's not it. This is open twice for some reason. There we go. Say A2. We did say A2. Oh, okay. This is not what I was looking at, I guess. Instructions? Where are you? I have too much junk going on here. Alright. A2. Nope. Reference. Yeah, okay, that's what I was thinking of. Let's drag you over here. Somewhere useful. There we go. Alright. A2. Go. Immediate load X. Okay. Read instructions. Read modify write instructions. This is absolute addressing. This is 0 page index. This is absolute index, which I think is what I want, right? This is, or no, this is immediate. Absolute 0 page. Okay, so where's immediate then? Okay. Index 0 page addressing loads never 50 page address. Oh, I guess absolute and immediate are the same. That was silly of me. Okay. So, fetch opcode increment PC, we've got covered. Fetch low byte of address increment PC. Fetch high byte of address increment PC. Read from effective address. So, again, where do we read it to? Is the question. And it looks like there's an address bus high register and an address bus low register. So let's just stick it in there. That makes sense to me. Address bus is U16. This is whoa, hello. All right, this is the other cat. All viewers observe. He's very squirmy. Oh, there we go. Now he's sitting down. Hello, buddy. How you doing? This one's name is Faint. He's a little bit chonky. Very fluff. Very soft. I am a crazy cat boy. I have multiple cats. But they're so cute. Yes, they are. Hello, buddy. You know what? I bet you're always going to fetch 2 bytes for address. So I should probably make it like... whatever. Who cares? Fetch address low, fetch address high, read from address. Okay. And then, oh, buddy, you're a little bit in the way, bud. Need you to move so I can read my screen. Oof. Here, sit on the cat chair. You want to sit over there? No? You can sit on my lap, that's fine. Just not in front of my screen. Okay, so, yeah. I do have a chair dedicated to cat because otherwise I never get any work done. I could probably make a lot of these a little bit more like reusable if I wait, where am I supposed to load it from? Oh, I'm supposed to load it from X. That's why it's LVX. Obviously. I really do need to figure out how to make these a little bit more user-friendly. Like, they need a certain number of arguments. I think, are there any 2-argument functions in the NES? No, well, there are because they're unofficial. That's right. So I'll just make it everything takes 2 arguments. And that'll be good. And then we can take things that take the PC as U8, U8, although actually I guess it'll just be around anyway, so who cares? U8, U8. Everything takes a minimum of 2 UOPs. Yeah, no, I meant 2 arguments, like add X, Y. And obviously that those do exist because you can add stuff into the accumulator, and also some of the like double instructions modify multiple things at once, which is kind of silly. Okay, so all of these need to take something. Fetch and decode doesn't need to take anything. Fetch to IDL doesn't need to take anything. Fetch and copy. Fetch address low does. So we're going to fetch the byte. Oh, I'm an idiot. That's not how that works at all. Yeah, that's dumb. No wonder. It's load 2x, not the other way around. The 6502 is so simple that I just expect it to be more complicated, I guess. Alright, so fetch address low actually doesn't need these arguments at all either, but I'll just leave them in place for now. You can always delete them later if they turn out to be unuseful. Fetch byte, CPU, get PC. The only difference is the target register here, is its address instead of IDL. And then fetch address high is exactly the same. Again, I could probably make some of these more reusable. Okay, and then read from address. To X. This is obviously the wrong way to do this, and I will clean it up after it works. Fetch address low. Address high. Read from address X. Read from address to X. And then this one is going to be CPU regs X equals CPU dot get byte, not fetch byte. And the argument is going to be CPU dot AD. Okay, so hopefully this will no longer explode on an invalid instruction. Oh, no field AD, it's AB. My bad. Address bus, not an abbreviation of address. Expected U16, found U8. Oh, yeah, okay. It's fine, we just want to take the lower butts. And then I obviously did that wrong. 16 lower bits. Expected 3 parameters, none of which are relevant. I do think that that was pretty dumb. I shouldn't have done it that way. Oh well. Address bus 0. Choo. Oh, you still exploded on A2 because I didn't put it in the instruction array. Just completely fair. And this one, we do fetch address low, fetch address high, read from address X. All right, cool. So it added all those to the queue. And this one should explode. Oh, I need to write it. Yep, here we go. Invalid instruction 0. Ominous. That seems like it might actually be invalid. Here are the notes. Instruction trace, where are you? I know you exist. I have you open in one of these tabs. I should close a bunch of stuff. That'll make it easier. Oh, that was next thing, so I'll leave that open a little bit. I have to close some of these. Oh, this is the NES test documentation, and then this is the log. Okay, here we go. So load X 0. Am I doing things wrong here? So is load X immediate actually just like shoving the value into the register? Because that would explain why this is cycles 2 and would make a lot more sense. Yeah, okay, that makes way more sense. I was looking at the absolute addressing mode for some reason. So let's just go ahead and change this to be that. Abs, AE, or actually I want to keep that, but I should add this one. Abs, AE, make this one abs, and that'll just look correct. And then I probably have all of the stuff, almost, except I need to be able to set X to a register. So what do I want here exactly? I want result, load X immediate. Instead of fetch address low, I think I want to do fetch to IDL, but let me see if... Oh, okay, so this just says immediate addressing must be all of these things. Fetch opcode, fetch value. Okay, so we're just gonna do fetch to X and then fetch and decode. And again, we're gonna need to fix that fetch to X thing because it's obviously dumb. And now all we need to do is write that, which is exactly a copy of fetch to IDL, except instead of IDL it's X. Regs.x. And now, oh yeah, okay, fetch to X, and then I need to actually put it in down here, and again, should really do better than this. Fetch to X, fetch to X. It still says invalid instruction 0, which doesn't seem right. Fetch and decode, read from address X is still in there. Oh, because I swapped the wrong thing. That's why. Go, baby, go. Okay, now you've exploded on 86, which is, I believe, the next instruction. Where's that trace? Here it is. Yep, 86. Excellent. You have exploded exactly where I intended you to explode. And if I delete these, that should be still explodey. No, just the next one. Oop. Okay, there we go. Alright, now is the time to pause and kind of clean some of this stuff up. So first of all, the fetch 2's need to go, because that's just bananas. So we're going to change from fetch to x to fetch to u8, or no, not u8. Enum reg names. PC, S, P, A, X, Y, IDL, AB. And we're going to fetch 2 reg names. And then when we decode these, instead of doing fetch to x, we're going to do fetch to reg name. And then we're going to return this, which is going to do CPU, or no, actually we need to do match reg name, reg names x, going to yield cpu.regs.x equals cpu.fetch byte, cpu.get PC. And then underscore, we're going to default to the PC, otherwise, even though it doesn't make any sense. Actually, we're going to default to IDL, just for fun. Fetch byte, CPU, get PC. Is this going to explode? Let's see here. Just because we didn't derive copy for this, or clone, or debug, all of which should be derived on it. Expect to closure that takes 3 arguments, takes 1 argument, right? I forgot. I should just get rid of that. It's dumb. Unknown field, IDL is not in regs, of course. Okay, and then fetch to x is gone. Fetch to reg names x. Boom. That seems to have still worked. So that's good. I like that. I wonder if there's a better way to do the function generation. I mean, I could always pull it out, I guess, but that's probably not super helpful. Whatever. It's good enough for now. So the next thing to do is to get rid of fetch to x, because it's dumb, and then also we're going to get rid of fetch to IDL. Reg names IDL. Alright, so we're going to get rid of that because it's easy. And 75, instead of u, we're going to get rid of u, fetch to IDL. This is going to be fetch to reg names IDL. It's the instruction data latch, I think, is what it's called. Where did I find it? It's in here somewhere. Oh yeah, it's the input data latch. That's right. It's right here. It's this thing. Because this is my solution to the problem of I was looking at this document for the jump instruction, and it shows fetch low address byte, then copy low address byte to PCL, and fetch high address byte to PCH. But copy it from where exactly? Fetch it to where exactly? I decided it was that input data latch. I don't know if that's real. It could be completely incorrect. But that's what I decided. And I will run into problems later if there are problems. Sai said I could call it Andrew or A Weigel is cool, but Sai has limited respect for such a thing. Pattern fetch to IDL not covered, right? IDL. There we go. There we go. Shoot boop boop. Seems plausible. I thought so. Okay, great. So we still make it to 86. Or 86, rather. If you would prefer. God, I love coffee. Sucks down coffee, more like. Alright, so what else is dumb and repetitive? I really hate and. And always makes me kind of sad. I'm going to need to eventually make the queue wider because there are going to be PPU operations that can happen on the same time slice. Sort attempted to make fetch and decode into fetch and decode, and then push them into a wide queue at the same time, but maybe that's not a good idea. Oh well, let's make what is read from address X supposed to be exactly? Oh, read from address to X. Alright, so let's do read to reg names. This isn't even actually used yet, but that's okay. Oh, I hit caps lock. That's why nothing's working. Shoop-a-beep boop. So the literal only difference here is that it's get byte and it's address bus. Okay. Well, this is obviously wrong also, but that's okay. Read from address X comes read to reg names X. And then in 77, I'm going to go ahead and get rid of that because it doesn't exist anymore, and now we're good again. Okay, let's see. There's not really any more super obvious cleanup unless I wanted to try to separate some of these, or if I wanted to break address low and address high into two different registers, I could do that. Yeah, okay, let's do that. Address bus low, U8. Address bus high, U8. Get rid of these two. What am I looking for? Oh yeah, right here. I need to add these guys here to ABL, ABH. And then down here, I need to add ABL, ABL, ABH, ABH. Again, there's definitely a better way to do this, but whatever. All right. And then when we do CPU.ab, Where's my impulse CPU? It's down here, right? Okay. Let's go past the instructions, I guess. Pub flim get AB self U16. Gonna return self.abl as U16 or self.abh as U16. Left shift 8. If you're not sure about parentheses, just go crazy. Alright, and then all the times when I do .ab, oh, hello. You really need to call first, buddy. Kitty, 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 kitty. He's a good cat. Alright. So everywhere that I have .ab, it should really be... well, these are going to go away. No one cares about these anymore. They're dead. This needs to be a function access everywhere that it was used previously, which I think is only in those 5 spots. Okay, and then we already deleted it from microfun, but we got to delete these 2. And then we got to go in here and replace these with fetch to reg names ADL and to reg names ADH. How goes it? It's going pretty well, Nick. How are you? Oh yeah, okay. I'm just removing some unnecessary duplication in a couple of spots. And then we'll get back to just cranking through instructions. What? Oh, it's a B. God damn it. No method named AB. Oh yeah, because it's get AB, because that's the convention. 2, 3. There's going to be one more, which is on line 59. 4. Go. There we go. Now we should die on 86 again, and we do. Excellent. Okay. Kitty, kitty, kitty. Nick, have you seen my cat yet? Here's one of them. He's a good boy. I know, right? He's super cute. Okay. Instruction 86. Let's do it, fam. Here's my big list O instructions. There it is. 86. 0-page store. Okay. Store the contents of the X register into memory. Okay. STX on 0-page addressing. Okay. Start with fetch opcode, blah, blah, blah. Okay, so const STX 0-page. It's 86. He's so distracting. Okay. Alright. So the microcode for this is result STX ZPG as usize equals vec microfun. Alright, so we start with fetch opcode, yeah. Fetch the address, which does that mean... Interesting. So, okay. If I'm reading this correctly, because it's 0-page addressing, it basically means that the upper bits are 0. And so I fetch the address only the low byte of the address, and that's why it's faster. Right? That makes sense to me. So we're going to do fetch to reg names ABL. And then the next thing would be write to, which I don't have one for. Okay, so then I think all I need to do is if I fetch to ABL, I need to also zero out ABH. Possibly I will regret this later, but it seems reasonable to me. Click at. Alright, so if I just fetch into ABL, that should handle that. Now I just need to implement write. Oh, and also, obviously, the next thing to do is fetch and decode. Should be fine. Okay, good. Glad to hear it. From someone who knows. Okay, micro fun write. Reg name. Match reg name. CPU underscore. I really should just get rid of that. It's not helpful at all. I completely misinterpreted what I would need to do. CPU dot set byte. CPU dot get ab CPU dot regs dot x. And then we're just going to default to doing exactly the same thing otherwise for now. This is good cat. Okay. Fun set byte and use self adder u16. Actually, maybe it's just regular self. Value u8 returns nothing. Self dot mapper dot set byte address value. Again, this is obviously wrong in the future because there will be writes to things that are smaller than that. Actually, it's wrong right now, come to think of it. So, okay. Because this is going to be right to the 0 page, which is definitely in the CPU. Sorry, but I need my arm back so I can work the mouse. Thank you. Okay. No, not mapper. I want the CPU memory map. So there's 2 kilobytes of internal RAM up to 800F, and then there's mirrors. Okay, so let's just implement that. If adder less than 2000, 216, then let effective adder equal, or well, let effective adder. Effective adder equals adder and 0x7ff. Cat, what are you doing? Why are you attacking my screen? He's like clawing at the screen. That's not a usual thing for you to do. Here, sit in the cat chair. Sit down and just chill for a minute. Okay. Add address not implemented. And then, let's see. I'll be interested to see whether Rusty can figure out that that's okay. And then we're going to do self.ram effective adder equals value. This does need to be a mute. We need to add RAM to our CPU. It's just going to be U8 semicolon. And then RAM is going to be 0, 100. What's next? Placing the GPU in the CPU struct. Hey, don't look at me. It's internal to the CPU. 2 kilobyte internal RAM. Says so right there. What are you talking about? No method name. Oh, it's just because I screwed something up in the CPU description and now it just doesn't exist. Okay. What dumb thing did I do? Button mode reusability. Whatever. What curly brace did I not close that is making everybody so angry? These all look more or less correct. What did I change? Oh, it's this one. Okay, there we go. Okay, better. 190, thank you. As use size. And chugga. Kaboom. Alright. This is the next thing that needs to be improved, is the ticking of the simulation in this test. Well, this doesn't seem to be right. Or maybe it is, actually. Let me look at the instruction listing. Load X, store X 0, store X 10, store X 11. So those are all 86s, which is why it works. And then the next one we should explode on is 20. Just add a bunch more. At some point, I'll just make this an infinite thing. Actually, right now, I'll do that. Don't see why not. While true, CPU.execute. Kaboom! Alright, so it exploded at 20. How are we doing here? You're probably going to want to be able to serialize your CPU state into a string in that same format. Yeah, you're absolutely correct. My original intent here was that I was going to like add. I remember I stole your MGUI stuff, so I was going to put like a debugging window that just always showed the CPU state and let me single step and blah 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 blah. But then I got interested in just implementing a bunch of instructions really quickly in NES tests, so that's what I'm doing now. Although really quickly is extremely up for debate because I've been streaming for 2.5 hours and I've implemented what, like 4 instructions. But it's getting smoother every time. It's fine. How many have I implemented? Exactly 4. Cool. All right. So I think I'm going to do one more, and then I need a break for dinner and, more importantly, cat dinner. Yeah, a lot of it was implementing boilerplate. Exactly. That's why it's getting faster every time. Reference. 20. Yeah, I'm going to implement one more, and then it'll be dinner time. I'll come back after dinner because I haven't done 4 hours yet today, and I said I would do 4 hours. This is JSR. Oh, that's fun. Subroutines. It's almost like a real computer. Uh-oh, it involves the stack. Everything is terrible now. Is that really how that works? JSR pushes the instruction, the address minus 1 of the return point on the stack, and this is the program counter to target memory address. Sure. It only has one addressing mode, which is absolute. It's 3 bytes. It takes 6 cycles. Okay. Cycle 1, fetch opcode increment PC. No, it isn't. That's the last opcode of the last thing. JSR only has 1, so I just will. I guess I could give it abs, but who cares? So you all basically like parameterize over addressing mode, is that right? I'll probably end up there. I'm already kind of doing that. In retrospect, I don't think the PPU is that hard. Yeah, I don't know. We'll see. Okay, so we fetch the opcode, we fetch the low address byte, internal operation pre-decrement S, push PCH on stack decrement S, push PCL on stack decrement S. Copy low address byte to PCL, fetch high address byte to PCH. Okay. So we fetch to ABL, that works. We don't know what we're doing here yet. Then we're going to microphone push reg names PCH, which I don't know what that is either. Oh, yes I do. PCL. Split. Split. PCH. PCL. Okay. That makes sense to me. And then copy low address byte to PCL, fetch high address byte to PCH, which we were already doing that somewhere else. I think it's called like fetch and copy. So microphone fetch and copy. Okay, so now we need a push. Push reg names. Oh, this should go away. It's not useful. Oh, I probably will want to implement that in line as well. Again, got to be a better way to do that, but I'll figure it out later. So I call it push. It takes a reg name, match on the reg name, reg names PCH. Gotta get rid of this too. CPU dot. Okay, so the stack is basically just a store and decrement operation, right? So we do set byte CPU dot get or dot regs dot s plus the stack offset, which is okay, maybe it's 0. This is going to be an as U16, and we want to set it to the value of the register that we're pushing, which is regs x, and then we want to do CPU regs s minus equal 1, right? And then underscore assert invalid register for stack push. If may be missing an else clause. What? Alright. Yeah, you're not gonna like this at all. Alright, fine. CP or underscore assert invalid register for stack push. How's that? Better? Can it apply unary operator not? Fight me. What are you talking about? It's a macro. Can you not do macros in... Alright, whatever. We're just literally not going to do anything in that case then. Choo. Push PCL, fetch to... Attempt to subtract with overflow. Interesting. So I did fetch to ABL. Oh, I guess my stack wrapped around. I look like the professor from Money Heist. I don't know what that is. I assume some sort of movie? Is that a compliment? I have no idea. Yeah, I was gonna look at this. I wanted to see how the stack push works. Yes, it's a compliment. Well then, thank you. There must be some other stack pushy instructions, right? Pull accumulator, pull, push, here we go, PHP. I really want some better explanation of the stack here. Read next instruction byte and throw it away. Interesting. Push register on stack, decrement S. Huh. Does the stack not start initialized at 0? Is that my problem? Stack pointer, 256 bytes of stack memory from 1 to 1F, an 8-bit offset to the stack page. Okay, so that helps. I knew there was an offset. So that needs to be plus 0x100. PHP in the interrupts also pushes stack. Stack pointer is 8-byte. Wait, 8-bit, surely. All stack reads and writes access 100 plus SP, which, yes, okay, I get that. But I think, well, I know what's happening is that my S decrement is wrapping around because I initialized it to 0, and I'm just trying to figure out if that's, like, correct. It seems like it would be. It's an SRAM register, probably. Well, I don't know. These funky NMOS processes, who knows? Hello, cat again. Let's just allow a wrapping subtract. Wrapping sub 1. It starts at FD. Okay, well that's helpful. Thank you. Where did you find that information? It should still wrap around though, probably, right? On subtraction. Power on state on NESDev. Okay, I probably just missed that entirely. Let's pull that up because that's going to be important. CPU power up state. Hello, thank you, friend. All right. P equals 34. I had it as 30. Close. S is FD. And then all this other junk is other junk. Okay. Dope. Alright, I'm gonna call it for now and get some food and feed my cats, who are getting increasingly irritating about food. And I'm gonna come back for, I don't know, at least another hour, probably hour and a half after dinner if you want to stop by. If not, totally get it. This is gonna be an ongoing thing. I'm pop back in and out whenever you want to. I appreciate you all stopping by. I'll see you again in, I don't know, a couple hours, maybe a little more. Thanks.